Welcome everybody to IPL's webinar on Design Thinking for Data, Integrating Product, UX Design and Data Science. Today's guest speaker is Hunter Whitney, who's a UX instructor, a consultant and an author in the space of design thinking, UX design, and in the combination with data science. A little bit about the Institute. Institute of Product Leadership is a global business school for technology and product innovators. We have a number of programs on offer, including an executive MBA program, which is an 18-month course, an ICPM, which is an online bootcamp course for about 20 weeks. And we also offer workshops for 3 days based on product leadership and technology management. We have a number of Fortune 500 companies as our clients, as our corporate clients. We partner with a number of reputed universities in India to deliver our executive MBA programs, an alumni base of around 1,600 and counting, and about 220 plus satisfied corporate clients since we started off in the year 2012. We also welcome you to find out more about our e-learning course, which is called Product Management Fundamentals. You can log into lms.productleadership.com to find out about the course and sign up for the course. You're also welcome to join us on LinkedIn at the Product Leaders Consortium. Please search for Product Leaders Consortium and join the group. You can also post the queries and questions you have today for Hunter on that forum, and we'll have them answered by Hunter for you. Now, one of the lucky attendees today is going to win the book called Data Insights, New Ways to Visualize and Make Sense of Data, which is written by the speaker, this is Hunter Whitney himself. You can type in your questions in the chat window, the Q&A window of GoToWebinar. You can also tweet at ProdLeader, #ProdEvents. Now, a little bit of introduction about our guest speaker of today, that is Hunter Whitney. Hunter is a consultant and instructor and an author who brings a concoction of very interesting disciplines of user experience design and data visualization together. He advises corporations, startups, government agencies, NGOs to achieve their goals through thoughtful design approach to digital products and services. He's also the author of the book that I was talking about, Data Insights, New Ways to Visualize and Make Sense of Data, and a numerous number of articles covering different aspects of user experience and the design science. He also is a curriculum advisor for data visualization and UX design program on Coursera. He's also a guest lecturer at the Northeastern University's analytic bootcamp programs. So we are very happy to have Hunter today with us to talk about the very interesting topic of design thinking for data. So without any further delay, I would hand it over to Hunter to talk about his topic today.
Oh, good. Thank you. Thank you. Okay. Well, welcome everyone. I'm really looking forward to talking with you today about this topic, the title of which is More Than Meets the Eye, Design Thinking for Data. And I'm going to share my screen. All right. Very good. Okay, so I had a very nice introduction there, so I won't repeat my the introduction. I am a consultant, and I teach on also teach on data visualization and user experience design, and the combination of those things, and enjoy writing about them. It helps me think about the topic myself. So I think many people in this audience probably have some sense of an idea of what design thinking is. And there are very many formulations and descriptions of design thinking. I'm going to really focus on what it means to me. Now, for one thing, it's a process. There are a number of steps to it, and different organizations have different labels for different parts of the process. The one that you're looking at right now is from the D School. One example has empathy, define, ideate, prototype, and test. And I'll look at some of these steps in the process. But first, I'd like to refine it down to something a little bit more concentrated version. And so for design thinking in the most concentrated form for me, it boils down to essentially these steps. Define the problem, design solutions, test them, and then repeat the process. That's an inevitable part. Now, for my purposes and the purposes of the discussion today, I'll also talk about design thinking in relation to perception, cognition, how people see data and recognize patterns of data in visualizations, and also the data ecosystem. Now, while design thinking is a process, I also think of it as a mindset. Essentially, design thinking is an approach to solving problems. And when I think about design thinking, I think it's important to really understand the individual steps and sort of internalize them and have a mindset about them rather than follow them blindly. And I'll explain that with examples, what I mean. So we're going to consider 5 elements to design thinking and see how they apply to working with data. We're going to talk about how to empathize with users and customers to understand their point of view and improve the product experience for them. We're going to look at how to define users or customers or audiences so that we really understand how to design for the appropriate problem and the appropriate context. We're going to consider the larger data ecosystem as the context for the users working with data and think about putting different aspects together to make a final, say, data product, whether it's a data-intensive application or something else, effective and useful for the audience. I'm also going to talk about testing and refining your design and your design thinking or the product based on user feedback and testing. And at the end, I'm going to spend a little bit of time on some do's and don'ts based on the topics that we're going to be talking about today. Okay, so first, in design thinking and in user experience design, the term empathize comes up a lot. It's a wonderful term and important. We really need to understand and get inside the minds of the users who we're designing for, or in some ways working on products that they're going to be using. So I'd like to start with an example of a kind of a classic design thinking challenge and solution that really highlights the idea of empathy and the value in actual practical use of empathizing with your users or customers. Now, what you're looking at here is an MRI machine. And they are very powerful ways to image different issues going on inside their bodies to see what's going on in there. But they're also, and they're very powerful for diagnostic purposes, but they're also quite scary. They look intimidating. They make quite a bit of noise when they're in operation. So it's, by and large, not a very pleasant experience. This is especially so for children who also need to have MRI procedures done occasionally, and very frightening experience. And in this particular case, an engineer with GE named Doug Dietz noticed that some of the patients, the children who were using the MRI, were terrified, frankly terrified, and wanted to think of a solution to help improve the situation. When you're in an MRI machine, you want to not move around too much so you can get a clear, crisp image, and anxiety certainly does not help with that. Now, there are many possible ways that this challenge could have been addressed. And they're all valid, they're all reasonable. One is to re-engineer the machine to make it quieter, and I'm sure that's an ongoing process. If there are restraints, maybe they can be improved to help immobilize the children as they're being imaged in the MRI. You could up the meds before the procedure to potentially sedate or relax the children more. But none of these, I think we would all agree, are especially attractive or optimal solutions. They may be necessary, but not optimal. And this is where the power of empathy comes in. We're really solving for the human experience here. So, well, what does that mean? We're not thinking about a generic patient or a generic customer. What's really the core here is that we're empathizing with a frightened child. And that's the kind of brilliant insight that Doug Dietz had. What's it like to be inside the mind of a frightened child, and how could that fear be reduced? Well, he said, why don't we turn this fearful event into something fun and interesting? And so, through some very clever design, they transformed an MRI machine from this scary-looking device to a pirate ship. And or a pretty good rendition for a medical device, I would say. And they had the healthcare practitioners, the nurses and so forth, who were working with the children, dress up in pirate costumes. And the whole exam became not an exam, but a pirate adventure. And lo and behold, the children were much more at ease, did not require the restraints, did not require more meds, in many cases, that this alone, the psychology of their adventure, helped them to overcome their fear. And it's the empathy, it's Doug Dietz's and it seems empathy and understanding of what would appeal to children, their mental welfare, came into play here, and they came up with this wonderful design. So this is an example of design thinking. Instead of solving for the machine or solving for medications, essentially they solve for the child's psychology. So in a sense, I think as a user experience designer who works with product development all the time, I think there's a difference between the product and the product experience. The MRI machine still operates the same way, it's still the same device, but the product experience around it has been completely transformed, and that led to very practical benefits all around for everybody. So, in order to empathize with people, you need to understand who they are and what they're dealing with. So, I believe that definition is an extremely important part of the process. You can't design a solution if you don't define the challenges and contexts around the final answer. So, for the definition process, there are a number of areas that are important to clarify and understand, especially when it comes to users who are using data products. So in my case, often it's analysts, junior, senior analysts in, say, cybersecurity or healthcare, medical research, understanding where they are coming from. Now, it may be that what the products that you're producing are going to the general public, and sometimes that's also true for me. So there are very different needs and interests and goals of these different types of audiences. And this is especially true when it comes to data products and data visualization. There's a tremendous range in the outcome of the design depending on the type of user that you're working for and designing for. So it could be trained analysts to general public. It's also really important to understand, especially in the sort of data space, the purposes of which you're going to be working with your data and displaying your data. Is it for exploration and looking for interesting trends, patterns, predictions, anomalies? Or is it purely to explain something you've already discovered? Also, it's important to understand the use patterns of the users that you are targeting. Are they using it all the time, or is it something that's once only, or at best very infrequent? That will have a lot of impact on the level of explanation, complexity that your product, your design has. Of course, when someone's using something all the time, they'll learn it. The learning curve is different than someone who's going to use it only once, where there's an expectation perhaps of an instant understanding and unnecessary to learn anything more deeply than that. Thinking about the timing of the data that's coming in and being used by your users is extremely important. Is it something where there's data coming in all the time, rapidly, say in an operating room? Or is it something where there's a very, very slow process and the data has to be retrieved from a data warehouse? You know, thinking about the users and the data they're working with in terms of depth. How much detail do they want? Do they want something that's very precise and easy to sort of slice and dice in different ways? Or do they want something that's extremely summarized? And finally, the criticality. How important is this data and the interpretation, understanding, working with this data critical to their work or jobs versus something which is just general interest, a little factoid or tidbit that you might see in an infographic. So these are all things that are important to define and consider at the outset of your design thinking process. And these are not necessarily the only ones, but these are some of the main ones in my mind. So I work on data visualization designs and displays, and I use different types of spectra or continua to think about how to locate my users within that and what kind of design that I want to produce that will be best for them. So we looked at, in the prior slide, the idea of exploratory visualizations and explanatory. And where you locate your audience in this sort of continuation is important to think about. Do they need more exploration powers? And if so, they may need more control over the interface that they're working with, the tool that they're using to explore their data. Is it something that's going to be very dynamic in presentation or very static? I could spend probably half an hour on this slide alone, but I'm going to move on. But I want to make the main point that there's always a continuum and that there are different aspects of the user's experience that need to be considered, and ideally in relation to each other. So in the data flooded, the data-intensive environments that we work in, there are many types of people who interact with data along the process of working with it. And in a typical project for me, I'll be working with engineers, data scientists, analysts, and executives, all of which will consume data, but they'll consume data in different ways. And in addition to that, there are now, more and more, as we see, artificial intelligence and machine learning elements that are also working with data. So there's not only a spectrum and range of users who are consuming this data, but also systems that are consuming this data and doing things with it that are then put back to human users' interpretation. So it's this process that term was coined, humans in the loop, that there's a full data life cycle and that humans are touching all these different aspects of that life cycle. And that it's important to be aware of who they are, what they're doing, and what their needs are. It's really an interesting time because with the advent of big data and machine learning and AI, the roles of human intelligence and interpretation, curation, all those things are becoming less clear. They're becoming more blurry than they used to be because now machines can increasingly take on more and more of the role. So it's really, when you think about a user or consumer of data, it's important to think that their role is ever changing and will continue to change as technology evolves. And that the presentation and interpretation will be affected by the role of the machines in this process as well. Nevertheless, for design thinking, it's known to be, and I consider it to be, a very human-centered process and always will be. That the human experience is a cornerstone of design thinking. And to that end, it's, as I said, it's important to understand the people and define the people that you are working for and designing for. And one of the core tools for that is what's called a persona or user profile. Sure, most of us are familiar with it, but for any who are not, it's essentially a very short description of a target user in a particular segment. It's not an actual specific user, but it's an archetype of people who fit within that demographic or that target zone. Now, they may be an archetype, but they're very specific. You want to define your users in ways that you can empathize with them. If we just made a generic user, for example, for the MRI machine, just said a generic patient, we really wouldn't have the insight of fear and the insight maybe that they're of the powered adventure that would help this child lose that fear. By really clearly defining who you're designing for, you can then develop a better sense of empathy, and through that empathy, you can develop interesting design solutions that may not have been considered otherwise. In this case, I have a cybersecurity analyst who works with data a lot. It's important to describe their needs, their goals, their wants, their challenges, and also you'll notice on the right-hand side there everything from their ability to analyze data to maybe their level of patience. So that's, again, sort of an example of a bit of design thinking there. It's not just thinking about the analytic skills they have, but also their emotional state, their experience. And let's say this analyst does not have a tremendous amount of patience for investigation. That may make some important, have important implications for your design and how you make it as quick and painless as possible for this person to do their investigation. Okay, moving along. I would like to talk now about the idea of synthesis, putting the pieces together in the data ecosystem. So we're just talking about the critical component, you might say, of the data ecosystem, in my view, which is the person, the people who are involved behind it. But of course, they're working in a context, and that context is a whole ecosystem of data, which has variations of segments, but essentially, I'm going to describe it this way. There's a planning and preparation stage, a data collection stage, an analysis and summarization part of the process, representation through communication and so forth, and then acting on those changes. And then because this is, of course, an iterative process, starting the whole thing over again. Whatever you learned in the implementation, management, action part of the process may lead into the next round of data collection and so forth. I also put an inner ring here of metadata. I think it's often an overlooked challenge that data is not necessarily well sourced. The provenance of that data is not clear. So in a cycle like this, if you don't know where the data comes from, how it was collected, how it was used, and so forth, it can be a problem. How do you trust it? So the idea of metadata is extremely important in the data lifecycle process, and something that is not really well built, in my view, into the design process and can be improved there. I'm going to talk about a couple of little points here in the cycle, data collection cycle first, and that is that there are many different ways to collect data. And depending on the purposes and needs, it can be very straightforward. You know, data seems like it's not subject to human frailty or psychology, but of course it is. So in the process of data collection, it's important to recognize the human dimension again, to recognize the capacity of humans to have inadvertent biases and skew the data in ways that are not intended. So I'm going to tell you a little story here to illustrate one way that unintended bias can happen. So in World War II, many planes were being shot out of the sky at an extremely high rate, and the Allies wanted to figure out how to protect their planes better. And one way to do that would be putting a lot of metal armor on top of the places that were vulnerable, so that potentially when the planes were hit with ordnance, that they would be able to survive. So what these investigators did was they looked at the airplanes, they looked at the damage, and made a little kind of diagrams to show where the main damage was in the planes that they looked at. That when the planes came home, they surveyed them, mapped out the places where there was damage, and then the natural thought for many people, I would ask you in the audience, but think for yourself, what would you do in a situation you have this data you've collected come in? And how would you solve this? So you have this sort of pattern of damage. If you add, the more metal and protective plates you add to this plane, the more weight that plane has, and the more and sort of a downside. So you want to optimize, not too much protection, but not too little, based on this. Well, many people would say concentrate the protection on the places where there's the most damage. Seems reasonable, but and if I was speaking to you live, I would ask you in the audience to propose some suggestions about how to solve this. The most obvious answer to most people is actually not the best answer. Putting the armor on the places where the holes are is actually not going to protect them. Why? Because what they failed to consider was the planes that did not come back. They only surveyed the planes that did, that were damaged. The ones that sustained the most serious damage never came back. They were lost out in the deserts and forests. And their patterns of damage were unremarked. So therefore, the missing data was really the crucial data. And if the investigators had only taken the data that they had in front of them, they would have come to just about the opposite of the correct conclusion. So that's called survivorship bias. And I'm going to talk about one more kind of example of kind of unintentional bias when it comes to data and how data is presented and worked with. Now, in this case, the patient here, Nancy, is being told by her physician that she has a positive mammogram. And that's a test, it's a screening test to look for evidence of breast cancer. Now, neither of them has really enough data here. And so they're both not really sure what a positive mammogram means. The patient believes that she probably has cancer because of the positive mammogram. And the physician thinks she's got extremely high chances, 80% chances of having cancer. Now, both are wrong. Both have one insufficient data point, or then applying their own psychology and biases potentially to this. They're anchoring around the fact that it's a positive result without really understanding the underlying data. Now, in the physician's case, The reason why she's coming up with 80% is that she is already kind of anchoring around this idea, mentally anchoring or centering around this idea that Nancy has a positive test. And therefore is looking at this column here, you can see, it says has breast cancer. And for people who have breast cancer, 8 out of 10 of them do have a positive mammogram. But what she's forgetting to consider, or neglecting to think about, it's been a long time since she learned this, was that the vast majority don't have breast cancer, even with the positive mammogram. She's forgetting this other column of data. She's just thinking about what's in the first column. Now, how could this be solved? Well, we can start thinking about different ways through sketching to present this data so that it would be understandable to the patient and to the doctor, and that they could have a more meaningful conversation around interpreting the data, understanding the data that's presented to them. Now, in this case, this is a very simple sketch to start thinking about how to present data and talk about data. In this case, I simply did a kind of a tree diagram here. I branched out and said of 1,000 women, how many tested positive? And then out of those, how many actually had cancer? And when you see the actual numbers and sort of highlights, it's easy, whether you're a trained physician or a patient who's afraid, you can look at these numbers and understand them because they're put in more common terms, a different language. It's the same information but put in a different way. And in this case, the answer is essentially that it's not 80%, but more like close to 8%. So when you're thinking about working with data, there's the communication aspect of it, there's the understanding aspect, there's potential bias of it. But with design and thinking about design and presentation, we can help minimize those biases or help counteract the human tendency to take data and potentially distort it in ways that are unhelpful. So I've given a lot of examples now of how humans can potentially distort data and misinterpret data. But there's also another factor, and again, this is often unintentional, but is introducing error through mistakes, errors, entering bad data into a system. And there are often, generally speaking, there are two kind of main types of problems. One is that I'll discuss today. One is problem of type. That is, if I'm entering a phone number into a system, that I want to make sure it's going into the right field. I'm not entering a phone number into a credit card field. That's a problem of type. My phone number is correct, but I'm putting it in the wrong place. Or a problem of quality. So in that case, I'm putting the phone number into the proper field, but I've mistyped my own phone number. Silly me, but there I did. And when I'm doing that, and with enough volume, that creates problems for data interpretation and usage. If you have a lot of garbage in your system, you're going to get a lot of garbage out. And I have the acronym at the top of this slide, GIGO, garbage in, garbage out. So design can help with this process, just as it can help with correcting potential biases of data collection and interpretation. Designing data products at different levels of this process can help prevent bad data from going in, which could then ruin your results. If you're, say, a business analyst, you want to make sure that data you're looking at is the right data. The KPIs, the key performance indicators, are based on truth and not mistakes. So it's important in design to think about not just the output, but the input, and making those design features good. So if you're putting potentially bad phone number in there, maybe it'll signal you, it'll flag you for that. It'll give you preview screens. It'll make sure that the data going in is not going to be screwed up, because once it's screwed up, it's a lot harder to go back and fix it. And I do a lot of work with hospitals and medical companies, and so I'm interested in this particular area of data management for medical data. And one of my favorite stories is from a mentor of mine, Ben Shneiderman, who was asked by a hospital to look at some of their medical data. He visualized it without a particular agenda in mind, just wanted to see what things looked like and see how good their data was. And he noticed something interesting. He noticed in one of the plots that he created a bunch of outliers in the age group, and those outliers were 999 years old. And of course, they must be doing some very good medicine there for patients to live to almost 1,000 years. But in fact, it was an error. It was an error that was repeated many times because of a problem with their coding system. So patients, I believe, of unknown age were put in coded with a 999, which became then their age range, their age, and this bad data skewed a lot of the results and metrics for the hospital. So again, design is important at every level of the design of the data process and people working with data. It's not just the final visualization looked at a doctor's office, it's the people who are entering as well. This is another topic that could go on for quite a while, but we're also in a very complex data ecosystem, which has implications for design. So there's more of a trend now for self-service analytics. You know, people who are more junior, different people in an organization, looking at data, want to do their own analysis, and this is a wonderful thing. Another trend is cross-disciplinary collaborations, that different people in the organization want to look at data and work on problem solving together. That's wonderful, but with this trend comes a challenge for designers and other people interested in the data lifecycle, and that is sourcing, as I mentioned before, making clear where this data comes from. And the more junior, say, the analyst is, or the more self-service things become, it may not be as obvious to the less seasoned people looking at this where that data has come from, and they may make assumptions about it that are incorrect. So from a design perspective and design thinking perspective, it's really important to help people understand where that data comes from. It may look like a pure bottle of water at the end to them, but without labeling, without understanding that it came from some mountain stream or it came from a highly organized water bottle manufacturing and production plant. It's really important for people to understand where that came from, and design can help. Okay, what I'm doing is trying to touch on various aspects. Each one of these topics that I'm touching on is its own full webinar, I think. But I want to give you a sweep, a kind of an overview of some of the main things that I think about. And as a designer working with data-intensive applications and data lifecycles, data visualization is really where I do a lot of thinking and a lot of my ideation. And I want to just spend a couple of minutes here talking about the tools that I use for ideation, for design visualization, and for communicating designs. So again, it's a little tougher when it's a sort of an invisible audience in a sense, but I'm going to ask you, how many sevens do you seen in this block of numbers? And you know, just take a quick guess. It's pretty hard to see them. So what I'm going to do is something called encoding, visual encoding, which is giving the sevens in this a particular set of design attributes. In this case, it'll be color, red, and kind of an intense color red. And everything else I'll assign a different design attribute, which is a light gray, and see what happens. Well, by doing that design encoding, that visual encoding, it makes it a lot easier to see the information that you want to stand out. It's a very kind of almost atomic level design principle that becomes very important in design and design thinking, especially when it comes to things like data visualization, of course. Now, design is always an optimization challenge. So, you know, just because something works when it's in a very kind of simple example like this doesn't mean it'll work when you start to expand it out. So if I added colors to every single number in that cube, it would quickly become the same problem I had in the first place, which is it makes it difficult to pick out the numbers I'm interested in. So there's a range of options here. But what's important to consider when you're thinking about design is to optimize for people's perception, for their understanding, and that you may need to do more than just simple approaches, that there's a number of different tools that you need to use. So in this case, if I try to do some very busy multicolor encoding of my data, which I see all the time, it makes charts hard to read. But if I just pick out one kind of encoding for one type of data, it's not quite enough for my purposes. So I rely on a kind of a whole tool set to think about design and helping communicate design using things like colors and orientation, textures, hues, size, and shape. These are all elements that I may include in my design process to help communicate data to the users that need it. And I'll have to mix and match these things and ideate and come up with various ideas. I may come up with 3 or 4 ideas based on this, these sort of idea of encoding. Also keeping in mind that whatever I see here in terms of visual encoding may be skewed by what I was talking about earlier, kind of perception and cognition challenges. I'll just make a quick note here. No matter how much you say I'm not subject to bias or perceptual tricks, or that I'm always able to see through anything that, and clearly interpret it, I invite you to look at these 2 central rectangles here. There's a dark gray one on the right, and then there's a gradient kind of version on the left inside that larger square. Now, actually, those 2 rectangles in the middle are exactly the same. They're both dark gray. There's no gradient in the middle one. And as I'm speaking to you now and looking at it, I cannot, for the life of me, not see the gradient. The actual gradient is in the larger square that's the backdrop behind it. But your brains are wired to interpret things certain ways. And that's been great from an evolutionary point of view, but it makes it a challenge sometimes for proper interpretation. So I just wanted to note that no matter what, our brains are wired the way they're wired, and that when we're designing, we need to consider that. Now, one other quick point here. When I think about design, I was mentioning this very atomic level of units for thinking about design, but there's a whole other level of thinking about the different charts, plots, diagrams, what's going to work best for users, and what's going to speak to them in a way that will make sense to them, not too complicated or not too simple. And there's a lot of ranges, but again, this is a topic for another time, but it's important to think about the representation and the user who's going to be using it, and think about what they need and how they'll be able to work with this. Another note again from this mentor of mine, Ben Shneiderman. When designing, the goal is not the dashboard or the data visualization. The goal is insights, is what people can learn from it, and ultimately what they can act on, what they can do with it. So the value is not to spend your time thinking about maybe the prettiest dashboard, but think about the dashboard that people are going to interpret properly and be able to do something with. Okay. And let's see, we've got a couple of more minutes here. We took a little bit longer. Is it a time check? How long can I have for the formal part of the presentation, Maria?
Hunter, you could go on for another 10 minutes.
Okay, great. All right, so I'm going to talk about thinking about data and the data ecosystem and showing data. It's important that you look at the individual specific metrics. KPIs are very important, but sometimes, in my experience, people can get so lost in the individual metrics that they don't see the big picture anymore. And it calls to mind the story, which I really, it's an ancient story, but I think is very true to this day for people working with data and thinking about data. And that is the idea of the 3 blind monks and the elephant. And very briefly, um, the idea is that the three blind monks were put in front of an elephant. Each one touched a different part of the animal, not knowing what it was, and recorded their findings. And one touched the tusk, thought it was a stone. The second touched an ear, which the guy thought was parchment, and a third touched a rope and thought it was touched the tail and thought it was a rope. Now, of course, in all these cases, they're wrong, and they actually ended up in the story getting into an argument about it. But the problem is that they were doing maybe correct assessment of their individual part of this, their particular KPI of the elephant, but they were not understanding that the whole thing was an elephant, and so their final results were ultimately meaningless. So, you know, when I talk about design thinking, it's really about thinking in the holistic way and problem solving in a holistic way, even if a lot of the work will be involving very detailed assessments. So let me give one other quick example very related to that. We see a circle here and a square, and that's how we'd interpret these two images. But if we gave a third image, a cylinder, we can say, oh, I see, that circle and square are just different views of that cylinder. This is a bit of triangulation. It's showing multiple types of information to help make it clear how they relate to each other and give full context. I'm not going to go into this too much, but essentially this image here, this dashboard, shows three different types of images, but they are connected to each other. So you look at one, you highlight one type of one thing on, say, the scatter plot or the map, and it will render the appropriate image for that section in all the other parts of the dashboard. Sorry, I'm going to skip over this one a little bit in the interest of time. I would like to give at least one more example from friends of mine over at the Farm Bureau Network. And this is talking about the idea of testing and refining your data products. So this is a company out here that works with farmers to help them improve their agricultural efficiency and productivity. And it's called Farm Bureau Network. They went out there, did a lot of assessments, collected a lot of data, try to help farmers figure out how to make the most of their seeds and what to plant based on the types of soil they have and so forth. So they came up with some very wonderful data-driven displays of how to optimize a farmer's yields based on the types of seeds they choose. This is all great. It's very data-driven. But they went back, and this is the, as I said, the third part, the kind of core aspect of design thinking, which is test and refine. And what they found was, with this type of purely data-driven design, that farmers couldn't fully use it. That while it was all accurate, it turned out that farmers couldn't necessarily buy every type of seed for every type of soil in their farm. So the designers went back and they made some modifications based on that that feedback from the users about how to work with data, and redesigned their product so that it reflected a kind of more real-world view of the farmer's process and what they could actually do. So it wasn't pure data and pure data analytics where they're assuming that farmers could buy 10 types of seeds. They're assuming they could buy 2 types of seeds, and this is how they could plant them. So I think that's the important part of this. And then once this is released, they may then go back and redesign this again and then test it again to see if they can further increase farmers' productivity. But the idea here is that data alone is not going to do it. You have to connect the data output, to the real-world problems that people are having and make it work for them. Now, I'm going to skip over, well, let me just say 2 quick notes. When you're refining and trying to simplify, it's important to get the right level of simplicity. I have for my television, when I watch television, I would love a very simple remote, but one button, say on the left, is not going to do it for me. I have about 3 remotes. Those are already too many remotes, and so that's too many for me. So it's finding the right level of simplicity to help your users. And in this particular case, well, this example, it was the person was needed to have, the father needed to watch TV, but wanted to watch TV, but was unable to figure out the remotes, and so his kid figured out this sort of UI hack to help him work with that data. He simplified it enough to highlight and point out what's important in this information. And I think that's important for us all to kind of think about when we're designing products or thinking about design of data products. That simplicity is not just the absence of clutter, that it's basically thinking about what's the right thing for the user at the right time and right place. I think this is often overlooked. Okay, and then closing, I just wanted to mention, I can maybe send these out, at least these do's and don'ts, but a few do's and don'ts for design thinking with data. It's important to think concretely about the people and context for which the data will be used. Not just a generic user, but say, for example, a frightened child waiting for an MRI. That level of concreteness can really help make a difference in terms of the design thinking that you do. Don't underestimate the influence of psychology in the design process, including bias. These are really important. I hear someone, maybe someone's on mute. I don't know. It's like a train going, almost. Do consider that empathy, while it's very hard to define in some cases, or it's a very kind of amorphous term, but it can be a practical problem-solving tool, getting inside the heads of the users. Also, don't assume that the way you think about data is the way that your audience does, or that, you know, the different types of users. So the patient and the doctor may think about data in very different ways. You need to account for all those. So there are many very different worldviews about the same input. I think no matter where you are in the process, a product manager, a designer, a data scientist, whatever you are, develop an awareness. Go talk to people in other parts of the project that are doing other parts of the data life cycle. You don't have to be an expert, but it's important to understand the fundamentals at least, so you do a better job on what you're working on. And don't assume that the data you're working with is going to be good. Assume it's going to be bad. Assume your data is probably going to be corrupted in some ways, and work with that. Try to improve it, or at least don't overinterpret it. Allow people to have flexibility in working with data. They like to work. People work with data in different ways, but don't use that flexibility of self-service to make it the user's problem. Whenever possible, help streamline and think about ways to guide them through something, and not just make it completely self-service where they have to figure out everything in the dashboard and how to put it together for a useful purpose. You know, do find ways to connect data and track data to make sure that people know where it's coming from, this provenance I was talking about. And don't allow things like artificial silos, like different buckets of data, to then obscure the full meaning of it. So don't let the tusk and the tail buckets obscure the fact that this thing belongs to an elephant. Prioritize the data based on the understanding of the users. Don't show everything. You know, try to find ways to make sure that it's clear to them. You know, what's important to them and what isn't, don't show. Things, you know, do consider things like interaction design choices like sluggish performance that can really make a big difference on people's interpretation of data, their workflow. They get into a flow of analytics. And don't forget that data dashboards are not the goal. It's the insights and actions. And don't try to oversimplify or undersimplify. And I still hear someone, maybe should I mute. Be open to different solutions. Try to ideate as much as possible with some of the tools that I was talking about. And again, think about it as an iterative process in which whatever you come up with will be altered by your customers' feedback. And with that, I'd like to thank you. Sorry for going a couple of minutes extra. Happy to entertain any questions that you might have. Thank you very much.
All right, thank you. Thank you so much, Hunter. That was a phenomenal webinar. And I think the examples that you gave about data and how to present data are, were extremely useful for us to understand what it really means when you say design thinking for data. There are a couple of questions that we have with me. May I request all of you to be on mute? There's some sound coming up. I think all of you.
Yeah,
May I request you to be on mute?
a little distracting.
Yes, quite distracting. So it really is not working with the theme of design thinking.
Yes, well put. Well put.
All right. So I have a few questions, Hunter, and of course there are many. So we will have them answered on our, the LinkedIn group. But let me
Yes.
take a couple of interesting questions for you. So the first question that we have um, from Srinivas is, can cognitive bias be exploited in a positive way to accomplish your objectives? So let me do this.
Yeah, that's a very interesting question. I think the answer to that is yes. It comes down to your objectives, I guess. Really, yes, I think so. I mean, this is an example, I think, of understanding the definition part, because that's a very good question. I think the answer is yes. There may be some ethical or moral things around it, but I would say back, the next thing is, what exactly is the definition here? So what is the definition of your user? What is the definition of your purpose? And so if I had that in mind, I could answer even more, effectively on whether it's whether this would work or not work. So that's why a fundamental part, when I have my sort of my three-part formulation for design thinking, it's define, design, and test. And that define part is so important, and getting into that concrete granular level. So I would say yes in general, but I'd need to know specifics.
All right. Thank you, Hunter. Another question that we have is, are infographics the best representation of data in the complex and interrelated world that we have? So would you say that infographics do justice to the kind of complexities we see?
No. Next question. No. Well, again, this is, I'm going to probably sound like I'm repeating myself, and I am, and I think that's good. Again, it comes down to the definition. Define your audience and your purpose. So I went through it very quickly, but you may remember I had a sort of a kind of a spectrum there of like explanatory and exploratory data visualizations. And for things like presenting certain kinds of information that you already know are very clear, you don't want people to interact with, infographics are great, but they're exactly wrong for some of the kinds of work that I do, which are exploring data in which you have no idea what you're looking for yet, and you need to interact with it. You need to actually kind of explore it and work with it, and that is almost a polar opposite of the static infographic. So for purposes, let's say like the 10 best tips for SEO, or for design thinking for data, for that matter, something where you have some bullet points like I just showed, infographics can be terrific. But for a lot of other purposes, looking at KPIs or whatever else, that's not the answer. So again, it comes back to the define part. What makes the define part so critical here?
Sure, fantastic. So I'll take two more questions, Hunter. So the first one is, very common question. What are the best tools that we can use for data visualization, and some reference books that we can refer?
Yeah, okay. So a couple of thoughts on tools. I actually teach a course on Tableau for Coursera. Tableau is a good tool, but again, for example, for certain kinds of purposes. But again, I know I'm repeating myself, and my apologies, but it's true. This is maybe the important point of illustrating this is it really depends on what you're doing. So, and defining your audience, your needs, your purposes, that will tell you what tool there is. There's a lot of data visualization tools. So, something like Tableau might be good for someone who's maybe more of a unfamiliar with data visualization analytics and maybe wants to move beyond Excel, but doesn't want to get into more hardcore things and doesn't want to have to do any programming or Python. So that's a good tool for certain purposes. But then things like D3, R, there's a whole raft of tools that are good and or combinations of tools, depending on if you're building stuff from internally to present or you're trying to pull stuff off the shelf. So, and it's constantly changing. My kind of thought about it is, and I can send out some tool references and maybe any follow-ups even offline after this webinar. I can send a couple of books and tools that I like currently. But I think one other point I want to make about tools is that I tend to be, tools are necessary to do the job, but I spend more of my time thinking about the sort of the bigger picture stuff, the things I was talking about today, because the tools will change, but the kind of processes that I'm talking about, how to approach your data, how to think about users and so forth, are going to remain. You know, the Tableau may disappear in 10 years, or maybe the dominant tool in the market. But knowing your users, understanding the human context is not going to change in 10 years. And that's actually quite a challenge. So, but I will, that said, I will still send out some tools. I understand the importance of that as well.
That'll be great. You know, it's just a sense of direction that people are looking at. Now, one last question, Hunter, before we close. So this is a question from Srinath, who says, please help us understand, when developing a product, how do we make choices on data that needs to be collected?
Sorry, it's a little bit, I get a little sidelined. How do they what?
I'll just repeat my question. So when developing a product, how do we make choices on the data that needs to be collected? Obviously.
Excellent question. Very excellent question. I mean, in a sense, I think it's a core to some of what I was talking about. As I said, it's sort of it's an iterative process. So I think, you know, it depends on where you are in your cycle. Remember that cycle, the data life cycle I showed? I mean, I often presuppose, in most of the cases that I work on, or instances that I work on, there's already data collected. It's not starting from absolute zero or scratch. So there's already sort of assumptions about it, and something's already been done. So I'll talk about that, and then I'll talk about the zero case as well. In that case, you know, I'll take what the existing data is, and then I'll start doing design around it and show people. So I'll take the data that's been collected, I'll design different types of approaches using data visualization to help make that data understandable to the users, and then with that that feedback, I can then better understand what data to collect the next round. So that's why I did discuss the data visualization aspect a lot, because, you know, it's important to show the state of the data to the people who will be using it. And from my mind, one of the main ways to do that for most people is through visualization. So that helps people to see what you've got and what they need or don't need from it, and how to improve it. Same thing in the zero case. It's a lot tougher, I think. You know, starting from absolute scratch is, again, it comes back to this design. You know, define first. So, you know, let's say it's a hospital OR. There are certain procedures, or certain steps, there are certain types of information that are important. And so the first step would be, you know, talking to the surgeons, the nurses, and so forth, and asking them, what do you need to see it, and when do you need to see it, and start to collect, and then start to collect. In terms of I think the beauty of like sort of iterative processes is that you may, over time, you know, as you're collecting data and then showing it, you can catch those biases. In relation to that, to the airplane example that I showed with the data collection, one of the things I think is interesting design approach is to take the data that you've got. You know, let's say that the data they collected from planes that returned, show that, but then show an alternative. And actually, I have a slide in there that shows this. Show the reverse image. So do visualizations that make you think in a different way. And I think that can be extremely helpful and underutilized. Like, recognize, basically it's like showing a visualization, and then for thought purposes showing what would it look like if we reversed it, which may lead to interesting insights. So I think, again, visualization is not necessarily the dashboard, is not the end result. It's prompting people to think differently, to be able to see things from different perspectives. That is really the beauty part of visualizing data. Does that answer it?
I think that was a great answer, Hunter.